Hello everyone, this is Joe and thanks for coming back for another video. In this video we're going to talk about power converters and power control centers. These are used primarily in recreational vehicles like boats and RVs, campers, trailers, etc. Let's talk a little bit about what a power converter does and how that compares to a power inverter. Power converter, and this particular model number is a PD4100, and it's manufactured by Progressive Dynamics Inc. And they're one of popular manufacturers in the RV industry that makes these converters. What a converter does is it takes AC from a shore power outlet. And what it does, it allows you to run, it has 3 breakers here. It allows a 30 amp input from the shore power, and then it allows you to branch out to 2 different 15 amp circuits. So it takes AC in, and then it distributes that AC out to the various circuits you have in your recreational vehicle. One of the other things that a power converter does is it converts that AC 30 amp current to a series of DC outputs, so you can then run some DC appliances in your recreational vehicle. This particular model has 5 DC outputs, and they are rated at 35 amps. Or up to 35 amps. So a power converter converts AC input power from shore power to DC, and it also has 15 amp branches to allow you to, again, use AC power within your recreational vehicle. Now what a power inverter does is just the opposite. It allows you to take 12 volt input and convert that to 120 volt output. So this is not a power inverter, this is a power converter. Another capability that a power converter has is when you're plugged into shore power, it has 2 leads that connect to your battery bank. And while you're plugged into shore power, it will charge your battery. Now this particular model is one of their newer models. It has a switch over here on the circuit board that allows you to select between lead acid, gel cells, and lithium ion batteries. So you can, as part of your storage battery solution, you can either use lead acid, a combination of the sealed lead acid, the gel cells, and lithium ion, which is a really nice combination. So you can start out using lead acid or gel cells, and then if you want to migrate or upgrade to lithium, this particular unit will allow you to charge any combination of gel cell, lead acid, or lithium ion. So let's talk about how you would connect a power converter up to your recreational vehicle. Your shore power, again, will come in through the distribution side of the box here. This on the right hand side is your power converter side. The left hand side is your distribution. So your main breaker here is 30 amps. So on your recreational vehicle, if you have a shore power connector, you would wire that, and most of them are 30 or 50 amps. In this particular case, this one is for 30 amps. So you would wire in your black wire to the breaker here, 30 amp breaker. Then you have a series of lugs here for your neutral or common wire. And then you have another set of lugs for your grounding connectors. So you would take your black lead from your shore power, tie it into the 30 amp breaker. Then you would put your white, your common or your neutral, and then your ground to the lugs here on the side. Then what you would do is In my particular case, I have two different circuits, and they're 15 amps. So then I can run my output to my RV from the 15 amp breakers out to the two different circuits. Again, you would also bring those Romex cables, and you would put the blacks or hots to the breakers. You would then run your common or neutral to the white bus bar, your ground to the ground bus bar. On the power converter side, you have 5 possible DC circuits that you can run. You also have a circuit board here with spaces for circuit breakers, and you would use or fuses. You would use the automotive style ATC fuses in this fuse block right here. So each of your 5 DC circuits, you can then put an appropriate fuse in here for the max amperage that you would want to control through these 5 black DC leads. There's also a second red wire, and it is labeled 002. This is if you have a need for a 30 amp AC circuit, and that uses the 30 amp main breaker. So if you had an appliance that required 30 amps, you could then wire that in through the second red wire. As you notice here, there is a fan, so it allows for cooling of the components on the power converter side. And you have a switch and a jumper in here to select between a gel cell or a lead acid. Then you also have an S1 switch, which allows you to convert between lead acid or lithium ion. So there's quite a bit of flexibility in this power converter control center. On the power converter side, there is also a black wire, and this black wire should be connected to one of the 15 amp breakers. This is where the power converter gets its power for its operation. You also will notice that the power converter also has a grounding lead and a neutral or common lead going to the bus bars here. So this is what provides the input to the power converter, and then your DC and AC circuits would then also be wired to either the breakers, which would be the AC side, and then the DC side of your grounding wires would go to the grounding plug. Your Romex AC connectors also will be connected to the neutral side bus bar and the grounding side bus bar as well. Another important fact that you need to be aware of is your recreational vehicle will also have a chassis ground. That chassis ground must also come in and tie in to the grounding bus bar. That way your complete vehicle will be properly grounded to the distribution side of the power converter here. So you always want to make sure that grounding lead from chassis ground of your RV is connected to the grounding bus bar. That way you have proper grounding of the vehicle, and you have proper grounding and return wires for your AC circuits, and then you also have proper connectivity to your DC side, and the grounding side of your DC side will also go to the grounding bus bar as well. What I'm going to do now is go out and show you how to install this in an existing RV, and that way you'll see how we connect up both the AC side and the DC side. So let's go out to the RV. There was an old power converter in the RV. It was over 20 years old. It was functioning just fine, but I went and did some searching on the manufacturer. This company was bought like several times in the last 20-some years, and there was a warning notice from the manufacturer indicating that this model, or a very similar model to this, had a potential shorting out problem where the transformer would ground out and would cause fires. So I didn't want to take a chance. Again, this was very old technology. The new technology doesn't use transformers, it uses transistors. So I decided that I would change this out to the new one, and we would recycle the parts in this one. So that's why I yanked it out. Didn't want to take a chance with any fire risk. What I did was I cut and enlarged the hole slightly because the new power converter was slightly taller and slightly narrower. So I'm going to fill in the gap with some wood, and then we're going to go ahead and start wiring. Because I want to track the voltage of my battery and the capacity of the battery in amp hours, I want to put a bus bar, and I purchased a metering system that uses a shunt. Basically what a shunt does is it allows you to capture the current going through the circuits without having to run very thick wire. There is a very small connector here. You can connect your large amperage wires across the shunt, and then you can use very small wires to go up to your gauge or monitoring system. So to mount this, I mounted this on a piece of plexiglass. Plexiglass is an insulator, and it will not short the two terminals out. So we're going to mount this, both the bus bar and the shunt, and I'll show you where I'm going to mount those. And then we're going to run a ground wire from the ground bus through the shunt out to all the loads. And these are all the DC circuits right here. So, and I don't want to necessarily track any of the capacity of the AC circuits, but I do want to capture what my current usage is across all of my DC circuits. So I'm going to show you how we're going to wire that shunt and that bus bar in to the power converter, so we can then watch and monitor what our capacity and the status of our battery when we are using battery power. When we're using the AC to DC conversion, I just want to know what kind of capacity in amp hours my devices are consuming. I'm not so much concerned about the status of the battery, because when we are on shore power, the shore power through this power converter is going to be charging the battery for me. What we've done now is we've taken the shore power 30 amp cable and we've routed the black wire to the main 30 amp breaker. We've routed the common or neutral white wire to the common bus terminal, and we mounted the ground green wire to the grounding bus. So now we have shore power wired in to the power converter. What we're going to do now is take the AC circuits, which are these Romex enclosed wires here, and these are rated for 15 amps. So we're now going to run these in through the back of the power converter, and we're going to wire these in to the 15 amp breakers here. We've now wired in the two AC circuits. As you can see, we have a solid wire going to the neutral or common bus, the other solid wire going to the neutral common bus. We have the two bare copper wires going to the grounding bus. We have one of the circuit's black wires going to that 15 amp fuse. We have the other black wire coming in from the Romex to the other 15 amp breaker, and then we have this wire which provides power to the power converter. It goes to the second 15 amp breaker. Then another thing that we did, we have some 10 gauge, and we wired this directly into the ground bus bar, and this is going to provide the ground side of all of the DC circuits, and this is what's going to go to the ground bus bar and the shunt for measuring current and voltage. So now let's go ahead, we'll mount this. I'll show you how we're going to mount the bus bar and the shunt, and then we'll wire in the DC side of all of the circuits. On the DC side, we have the red wire, which is going to go to the positive terminal of our battery bank. The white wire is going to go to the negative side of our battery bank. I'm going to wire those in later because I'm not really ready yet to wire in the battery and all of that side of the circuitry. The second red wire I have terminated because I'm not going to use this. I don't have any 30 amp AC circuit requirements at the present time, so I'm just going to terminate that with a wire nut, and then later if I happen to have that need to do so, then I can use that. Each of the 5 black wires here, each one of these is a circuit for 12 volts. So we're now going to take and wire in our 12 volt circuits, and for these we're just going to use wire nuts to the positive wires. Then on the negative side of the wires for the DC, we're going to wire those into the bus bar, and then we're going to wire the shunt in so we can monitor our voltage and our current draw. Another wire that I wired into the grounding bus bar, there's a large bare copper wire, and it's coming from the chassis ground. So that also was wired in through the back of the power converter and directly to the grounding bus on the power converter. I've now taken the power converter and I've now installed it temporarily into the hole that I cut out in the actual inside portion of storage area in the RV. And you'll notice on the right hand side there's a gap right there, and that's because the older unit was slightly wider than the new unit. So I'm going to take a piece of wood and I'm going to fill that in. We're going to sand it, putty it, and then we can then mount the cover on. As you can see on the left, this is inside the storage area. On the left is the shunt, and on the right is the grounding bus bar to all the DC circuits. The wires will be neatly tucked and zip tied together, so I'm just finishing them up right now. And I have yet to put the battery packs in yet. I will do that here in a bit, but I want to test all this out first. Let me show you how I wire nutted the positive side of the DC circuits. I have all of the positive wire circuits for the 12 volt now wire nutted, and the red, as you see here, goes to the battery. The other white and black wires all go to the circuit 12 volt circuit wires from the power converter. After I get all of this done, I'm going to wire tie everything up with zip ties to make it neat. The only thing I have to wait for now is I've ordered an assortment of ATC fuses for the front panel, and as soon as those come in, then I can do some operational checks. Let me show you the front panel and I'll show you where those fuses go. We've got everything wired up, with the exception of I have a water faucet that I have to wire in, but all the DC is wired, all the AC is wired, and I had some old fuses lying around, so I used those to test. And everything is working. Let me show you the I took my meter and I measured the DC wires of the circuits, and I'm getting proper DC voltage. I measured the battery cable going from the power converter up to the battery, and we are getting a charging voltage there. Here's the AC plug with the GCFI, and the green light is on, and I've checked all the outlets in the camper and everything is working. So the only thing I have left to do is to wire in the battery packs, run a line electrical circuit for the sink water pump, and we are ready to go. So thank you very much for watching. If you have any questions, leave them in the comments section below, and we'll see you next time.